2.4 equation of a circle. So what is a circle? A circle is a set of points that are the same distance from a fixed point or the center, like the center of the circle. So a lot of times for the scope of like the grade 10 course, what we're going to be focusing on is the center at the origin. So 0, 0 being the center. Okay. And the radius is the distance from the center of a circle to any point on the circle. Okay. So we would go from 0, 0 to x, y, whatever that x, y is. Okay. I want to show you kind of where the equation from a circle comes from, okay, because it's a mixture of either like the length or the distance formula and Pythagorean's theorem, since it's very similar, okay? So let's find the length of the radius of a circle using the line that starts at the origin, okay? So the line starts at the origin and ends at 6, -8. Okay, so if we were to plot these 2 points, and if you want to stack them like this, x, y, and then 6, -8, so we do 6 minus 0 and -8 minus 0. So we can do 6 minus 0, square that, and -8 minus 0, square that. Okay, if we were to simplify just the brackets, we actually have 6 squared plus -8 squared. Well, what is this beginning to look like? It's beginning to look like Pythagorean's theorem, right? So we have 36 plus 64, all rooted, okay? And so we have root 100, and we have 10 units. So radius is, let me say therefore, 10 units. Okay, so going back up to this picture, I'm going to go green, okay? If we had the origin and we had some point lying on the circle, and we took the x value, so whatever the x coordinate is, and we took the y value, so whatever the y coordinate is, we get the radius. So instead of calling this like A, B, and C, C being the hypotenuse, I'm actually going to call the hypotenuse, this time the radius. And that's where the equation of a circle comes from. So part of our curriculum is to derive the general equation of a circle. So first, what we'd want to do is we'd want to sub in 0, 0. We can also, instead of using x2 and x1, we can just sub in x and y. So our 2 points would be 0, 0, and then any points. So it would be the origin and then any point on the circle, x, y. So we would have x minus 0 squared plus y minus 0 squared. Okay, but then we'd simplify. Well, x minus 0 is just x, so we just get x squared. Then y minus 0 is just y, so we'd get plus y squared. Okay? We actually call the equation of the circle centered at the origin r squared equals x squared plus y squared. Okay? So if we take a look back here, if we squared both sides, so this squared would make this root go away. Sorry, this root go away. Here we go. And this squared would be left there. So it would actually be r squared equals, and because that square and that root are gone, that's where we get the formula from. So that's our equation of a circle. Okay, when we write this, what we actually want to do is we want to write x squared plus y squared, and that is never going to change, equals, we want to sub in the radius and then square it. So if the radius is 3, we would do 3 squared, which is actually 9. Okay, so radius 3, we would get the formula, x squared plus y squared equals 9, and we're going to see that in the next couple of examples. Write an equation of a circle with the center 0, 0. So just stopping here, the equation of a circle with the center 0, 0 is x squared plus y squared equals r squared. Okay, now the radius is 3, so r equals 3. We take that 3 and we simply sub it right into where the r is. 3 squared. We can't leave it as 3 squared. We need to simplify it. It's 9. X squared plus y squared equals 9 is a circle centered at 0, 0 with a radius 3. Now, write the equation of a circle centered at 0, 0 with radius of 1/2. Okay, same idea. X squared plus y squared equals r squared. We know that r is 1/2. So if we took 1/2 and squared it, so x squared plus y squared equals 1/2, but we have to square it because that's actually just our radius. We get x squared plus y squared equals 1/4. Okay, so we already kind of saw this one, but backwards. What's the radius of a circle defined by this equation? Well, I'm just going to rewrite this so it's bigger. Okay, so we know that this right here stands for r squared. So this r squared position equals 9. We need to find the radius on its own. I would root both sides. Okay, root 9 is actually positive 3, negative 3. So the radius is 3. The radius of negative 3 doesn't work because negative 3 cannot be a measurement, like a length. So the radius equals 3. Therefore, r equals 3. Okay, example 5. What's the radius of a circle defined by this equation? So again, x squared plus y squared equals 64. This number right here, 64, is in the position of r squared. So r squared is 64, but now we have to root both sides. R equals 8. Okay, and you can just skip to the r equals 8. You don't have to put the plus minus, but I just wanted to remind you that when we root, we have to consider both cases, and then the negative case doesn't exist. Okay, so therefore, radius equals 8. All right, example 6. A circle has the center of 0, 0. Okay, all this means, has center of 0, 0, is that we can use this equation. Okay, and passes through this point. Find the equation of the circle. So we only have a point, but this is convenient because this point is x comma y. All we want to do, if you think about it, 8 comma negative 6. So the circle would be like this, right? With this right here being the radius. All we need to do is pretty much Pythagorean's theorem with this 8 and 6. Because if we were to draw this triangle, this here would be 6 units, and this here would be our 8 units. So let's just sub in 8 squared plus negative 6 squared equals r squared. 64 plus 36 equals r squared. 100 equals r squared. Root both sides, and we get 10 equals r. Okay, so it says we can't just leave it as, oh, the radius is 10. It says find the equation. So x squared plus y squared equals this 10 squared. We're actually using the number from this. We're using this 100 equals r squared. I guess we didn't really have to root it because the number we're actually looking for is r squared. So x squared plus y squared equals 100. That is our equation. If we ever have an equation and we want to know whether or not a point lies inside, on, or, oh, that should say outside. Yeah, inside, which is less than, on, which is equal to, or outside of the circle. What we want to do is we want to take the equation and we want to sub in like negative 5 comma 9. Okay, because if you think about it, negative 5 comma 9, negative 5 squared plus 9 squared equals, let's actually find the radius of this one. Okay, this is 25 plus 81. So 25 plus 81, I get 106. So I get 10.29 equals R. Okay, to visualize, I have a circle centered at 0, 0. The radius is 10. So that point would be 10, and that would be negative 10. I have another circle centered at 0, 0. The radius is now 10 point almost 3. And this would be negative 10.3. So this point that lies on this outer circle, because this 10.29, the radius is greater than ours, it lies outside of the circle. So let me show you this. All I would do is actually sub in these two numbers, and I put a little question mark over here. Okay, so negative 5 squared plus 9 squared doesn't equal 100. So we have 25 plus 81. Okay, doesn't equal 100. So when we have 106, well, this is greater than 100. So because it's greater than 100, therefore, negative 5, 9 lies outside of the circle. Okay, last two. Example 7, a circle is centered at the origin. Okay, beautiful. Pass it through the point negative 3, negative 6. Find the equation of the circle. So very similar to the last one. We have the general equation of the circle, exactly the same equation as Pythagoras theorem. Now, negative 3 squared plus negative 6 squared equals, well, the whole point of us doing this is to find the radius. So I get 9 plus 6, 36 equals R squared. So I get 45 equals R squared. Okay, so R is approximately 6.7. Okay, we don't even need to go this far. We actually only need to go this far because in our equation, again, we actually want R squared. So x squared plus y squared equals 45. That's the equation of the circle that goes to this point. Remember, a circle, every single point on the circle will be like a radius measure away from the origin. Okay, last question. Stone is dropped into a pond, so right here, sends out a circular ripple. So we know ripples go out and out and out, and they bounce up and down as they go out, right? So this circular ripple increases by 5 centimeters per second, okay? It's 5 centimeters per second. Find the equation of the circle 12 seconds after the stone is dropped. So if we spent 12 seconds, that means that we would multiply 12 by 5 since the ripple is increasing by 5 centimeters per second. That gives us 60 centimeters. Okay, so right now, from the middle to the outside, so our radius right now is 60. That means x squared plus y squared equals our radius squared. X squared plus y squared simply equals 3600. And that's it. This is the equation of the circle.